In this workshop video, I'm going to go through the use of SABR's gear link feature that we have. Traditionally, you would have run a SABR model, taken all of the gear information, exported that out to an NGR file, opened up SABR-Gear, designed the gear, and then imported any changes back into SABR. We now have the option where we can link these two models directly, so we have a live link between these two files. So I will start this link. It will automatically fire up SABR-Gear in the background. Obviously it will take across all of the information from SABR into that gear file, and now I can look at designing the gear within SABR-Gear as previously, but there is now a link directly between these two files, so I don't have to export and import information between the two. So for instance, we can notice here if we have the face width set here and we have the face width in the background, if I change the face width here in SABR-Gear, it automatically changes within the SABR model. Similarly, all of the outside diameter information, module pressure angle and helix angle is all set within SABR-Gear, and that information is you cannot change within SABR. So the first thing I'm going to do is to modify the ISO settings. It's an EV that we're designing here, so I will change the application factor. I'll put in the root roughness values, the flank roughness values, and the lubrication. And now I will just put in some tip chamfers and the minimum backlash that I would like to have for this gear design. To start off with, I'm just going to run the optimizer and to sort out any of the geometric problems that we have, and to attempt to at least balance the ISO bending safety factors. So as a first pass design, that looks quite good. Everything's fine as far as the geometry is concerned. If I go back to SABR now, we did modify a couple of things, just the face width. I changed it back to the original, but that does mean that the SABR file needs to be rerun again to check the misalignment information and take that back across into SABR-Gear. So we'll run that information, but you will now notice it automatically updates all of the SABR-Gear load case definitions, so all of the misalignment information will have been taken across into SABR-Gear. So I can now check the duty cycle safety factors, and I may indeed be happy with this gear design. All of that information has been taken back across into the SABR file, and in the background, the SABR-Gear, the SABR model, if I save this information, then it has automatically created the SABR-Gear files and save those in a subdirectory underneath the location where the SABR model is stored, so this can be referenced directly in a PLM system, so that the link between these two is kept. The next thing we will do is look at improving this gear design in the next workshop video.